In this video, we're going to have a look at logarithms. What is a logarithm, why we use it, we're going to look at some log laws, and how we can solve some IB maths questions. So why do we use logarithms, and what are they? Well, if I were to say to you, 4 squared is equal to x, I'm hoping that you can try and figure out what x is, either using your brain or your calculator. But here, well, we can just square 4. 4 squared, x would therefore be 16. Okay, what if I said x squared is equal to 16? Well, you can figure that out by taking the square root of both sides. So you could type into your calculator the square root of 16, and with square root both sides, and x would be 4. Now, it could be -4 plus or minus 4, but for this sake, let's just take the positive value, as it's the same equation as the one above here. Now, where I'm leading to here is if I said, well, 4 to the power of x equals 16. Well, what does x equal? Now, with this example, you could probably tell me, oh, x is just 2. 4 squared is 16. And you would be correct. But if this was a question where x wouldn't be some nice positive integer, for example, 4 to the power of x is 21, you might think, ooh, what could x be? 4 to the power of 2 would be 16. 4 to the power of 3, well, that's 64. What could 4 to the power of x be? That's 21. And it's going to be some long, ugly decimal. And then even if I were to say to you, or you can use your calculator to try and solve that, a lot of students get to their calculator and they stop and they think, well, how do I actually solve for a power? And that's a very good question. If you want to solve for a power, if your power is unknown, we actually need to convert this into a logarithm. This is currently in exponent form. That's why this topic is called exponents and logarithms. And the way we can do that is we write this, and hopefully you can track the first formula up here. This first formula. We can write this as log base 4 of 21 is equal to x. And by converting an exponent into a logarithm, we can now solve for x. And this here is something you can type into your calculator. You can type in log base of some number and it will spit out the answer. So if you do type that in, you'll get 2 point something, maybe about 2.1 or 2.2. So, long story short, that's why we use logarithms. It helps us solve for a power. Yet in the first two, we could actually just use our calculator where if we want to solve for this, we just type in 4 squared. If we want to solve for this, we just type the square root of 16. But if we're solving for a power, we need to first convert it into a logarithm format. Okay, so that's a brief introduction of why we use it. Now I'm going to show you some examples. So let me create some space here. And hopefully as we go through each example, you can start to see the pattern. So if I were to say, well, log 2 of 8, what does this equal? And if you think about the formula that we just used, what this means is 2 to the power of what is 8? Now, 2 to the power of 3 is 8. So log base 2 of 8 has a value. This here is equal to 3. Okay, so if I were to write this in exponent form, it would be 2 to the 3 equals 8. But this is in log form. Let's try again. Log base 5 of 25. So this means 5 to the power of what is 25? Well, 5 squared is 25. So this equals 2. This here actually has a value and it's 2. Okay, what about log base, let's go with 3 of 27. Well, 3 to the power of what is 27? 3 cubed. So this would be 3. Okay, what if I had log base 7 of 7? 7 to the power of what is 7? And the 7 to the power of 1 is 7. So if you ever see log and the base in this term here is the same, we're going to get 1. Okay, a few more rules. If I have log base, and I'm just going to choose a random number here, 8 of 1. Well, 8 to the power of what is 1? Well, 8 to the power of 0 is 1. And that's a log law that we need to look out for. If you ever see a 1 inside of our bracket here, now some of these have brackets, some of them don't. Some textbooks put brackets, some don't, but they do mean the same thing. So if you ever see a 1 inside the bracket, the answer is 0, because anything to the power of 0 is 1. Okay, so hopefully you see some examples there. They do get a little bit tricky if you have something like this, log, let's say, base 2 to the 1 over 32. And this, if your indices skills are good, this is actually the same as log base 2 of 2 to the negative 5, because 32 is 2 to the power of 5. I can bring it up to the top line, and what we have now is log base 2 to the 2 to the negative 5, so therefore the power must be negative 5. 2 to the power of what is 2 to the negative 5? It's just negative 5. Okay, so I'm going to show you some log laws now. So let's rub this out. Hopefully we now know what a logarithm is and how to calculate it. So the first law I have up here in my IB formulas is the same base law, these two here. Now what the same base law is good for is if I said log base 6 of 2 plus log base 6 of 18. Now you might think, oh, 6 to the power of what is 2? I'm not quite sure. Well, go to the second one. Log base 6 of 18. 6 to the power of what is 18? Well, 6 to the 1 is 6. 6 to the 2 is 36. Not sure. Well, what we can do is we can use the same base law. And the first same base law here says if you have log plus a log and they have the same base, which these do, they have a c, and you have two terms, a and b, we can convert this into one log with that same base, which is why it's called the same base law, and we can multiply the two terms. So this will become log, we keep the base of 6, and we can do 2 times 18. Now this is useful because 2 times 18 is 36, and we actually do know what this is. 6 to the power of 2 is 36, so this is equal to 2. Okay, the second rule is actually the same rule, but it's a minus sign. So if it's a log minus a log and they have the same bases, you convert it into one log but divide. So if I had, for example, log base, and let's use 3 of 54, subtract log base 3 of 6. Each of these I don't know. I don't know what 3 to the power of what will give me 54, or this one here, but I can use the same base law that says if this is a minus and they have the same base, I'll have log base 3, and I'll have 54 divided by 6. Now this is log base 3, 54 over 6 is 9, and log base 3 of 9 is 2. So very good law, this one. Okay, this law here is called the power law, this one here, and what it says is if you have a log to a base and your term has a power, we can bring that power down out the front as a coefficient. So an example of that might be log, if I were to say log of log base 2 of 8 to the power of 5. Now 8 to the power of 5 is a huge number, and 2 to the power of what is that? That's beyond my calculation skills, but what we can actually do is use the power rule, which says we can bring the 5 down at the front, and we'd have 5 times log base 2 of 8. Now log base 2 of 8 is just 3, so 5 times 3, this is 15. Okay, and finally, we have the change of base rule. Now this isn't asked as much anymore in IB maths exams, but it is something that still might pop up, so you do need to be prepared. And what this says is if we have log base b of a, we can actually convert this into a log over a log, so with a fraction, and we can introduce a new base. And now the original term a stays there, and the original base actually becomes the term on the denominator. So this is a bit of a tricky rule. I suggest that you try and attempt a question and maybe watch the video to fully grasp that rule there, the change of base rule. So just before we finish up, I'm going to introduce one other interesting part about logs is this e, log base e. So let me create some space here. If you see log base e, this e is actually a number. It's Euler's number, or Euler's number, depending on how you pronounce his name. And this e is a number, 2.718 ... It's some famous mathematics number, just like pi. And this is called a natural logarithm. So this is actually shortened to ln of something. Now it has, there's a good reason why this is a base that we commonly use. It's to do with compound interest, and you might do a maths assignment on what e is and why log base e is important. But I just want to show you that all of these laws will still apply if you have this log base e. If you're adding natural logs to each other, we can use the same base law. If you have a natural log with a power, you can still use the power law. So you will see some questions where there's ln, and that's actually just the same as log base e. So if I had a very simple example, if you did see ln of e cubed, what does this equal? Well, I can bring the 3 down. This is 3 ln e, and ln is the same as log base e of e. So e to the power of what is e is just 1. So 3 times 1, this will give me 3. So don't be too worried if you see this ln when you're first starting out. It's just a log with an interesting base of e. Okay, so I highly suggest you work your way through some questions. Use your log laws, and they're not actually as scary as they originally look. Okay, good luck.